So how do we solve these three system of equation? Using the inverse method. Remember, we are going to follow the same approach that is used to solve two system of equation. So in doing that, the first thing that we are supposed to do is to write the matrix equation for these three system of equation. And in writing the matrix equation, we are just going to pick the coefficient of these variables to put them in a bracket. So we are going to have then we have multiplied by x, y, and z is equal to this. So let's call this matrix matrix A, let's call this matrix matrix X, and let's call this matrix matrix B. So from here we can say that matrix A times matrix X gives us what? Matrix B. Now we want to find X, which corresponds to these variables. And we have learned that when you have a matrix multiplied by its inverse gives us what? A unit matrix. Since we want to make X to stand alone, then we have to multiply both sides of the equation by what? The inverse of matrix A. So we shall have, and we also said that a matrix multiplied by its inverse gives us what? A unit matrix. So this is going to give us what? A unit matrix times matrix X is equal to inverse of A multiplied by B. We have also learned that when you have a unit matrix multiplied by any matrix at all, it gives us the matrix back. So this is going to give us S is equal to the inverse of A multiplied by what? B. So this is going to be the formula that is going to help us to solve this three system of equation. So we have our X is equal to the inverse of A multiplied by B. So first of all, we have to first find our inverse of A. And we know that the inverse of a matrix is given as the reciprocal of the determinant of that matrix multiplied by what? The adjoint of that matrix. So we find the determinant of matrix A. So to find the determinant of matrix A, we are going to pick any row, then we multiply each entry on that row by its cofactor. So let's pick the first row. So we have, and then we are going to collapse this column, and then this row will be left with neg 2, neg 1, 1, neg 1. Then we have minus 2. So we collapse this column, and then the first row we are left with 3, neg 1, 2, neg 1. Then we have plus 2, which is this. We collapse this row, we collapse this column, we are left with 3, neg 2, 2, 1. So we find the determinant of these entries. This is going to give us 2 plus 1. We have minus. This is going to give us minus 3 plus what? 2 plus 2. This is going to give us 3 plus what? 4. So we have our determinant is equal to, this is going to give us 3 plus 2, and then we have 14. So our determinant is going to be what? 19, right? Good. So determinant of matrix A is equal to 19. So we are done with the determinant. The next thing that we have to find is what? Our adjoint of matrix A. And we can find the adjoint by first finding the minus and then the co-matrix, and then we transpose the co-matrix to give us what? Our adjoint. So we are first going to look at what? Our minus. So we have minus for the first row and then the first column. We are going to have, so we are going to collapse the first column and the first row. We are left with, then we find the determinant of this. This is going to give us 2 plus 1, and we have what? 3. Then move on to the minor of the first row and then the second column. So with that, we are going to collapse this, and then that. We are left with 3, neg 1. We find the determinant. He is going to give us neg 3 plus 2, and that gives us neg 1. Then we find the minor of the first row and then the third column. So we have this and that. We'll be left with 3, neg 2, 2, 1. Then we find the determinant. We have 3 plus what, 4, and that gives us 7. Then look at the minor of the second row and then the first column. So we are going to collapse the second row and then the first column. So we left 2, 2, 1, neg 1. So we are going to have neg 2 minus 2. That gives us neg 4. Then move on to minor of the second row and then the second column. So we have this and that. We will be left with 1, 2, 2, neg 1. So we have neg 1 minus 4. That gives us minus 5. Then we look at M2, 3. So we are going to collapse this and that. We will be left with 1, 2, 2, 1. So we have 1 minus what? Minus 4. That gives us minus 3. We are going to follow the same approach to find the rest of the minors. So this is our minors. To find our cofactors, we just have to multiply the entries by these sign arrays. So we have plus minus plus, minus plus minus, plus minus plus. We are going to multiply each of these entries by the sign arrays, and we are going to have what? Our cofactors. So we have, so these are cofactors. To find our adjoint, we are just going to transpose these cofactors, and in doing that, the first row will become the first column, the second will become the second column, and then the third will become what? The third column. So we have the transpose of the matrix. We are going to have 3, 1, 7, 3, 1, 7, 4, neg 5, 3. Then we have 2, 7, neg 8. So these are transpose of the cofactors. Therefore, our adjoint of matrix A is equal to the whole of this. So now we have our adjoint. So we have our determinant. We have our adjoint. We are just going to substitute these entries into the formula. So we have our inverse of A is given as 1 over the determinant. The determinant is 19 multiplied by what? The adjoint. The adjoint we have. So this is the inverse of matrix A. To find our x, we are just going to multiply this inverse by what? Matrix B. And matrix B, we have 5, neg 6, 1. So we are going to what? Expand the bracket. So we have our x is equal to 1 over 19. Let's expand the bracket. This times this will give us 15. Minus this times this will give us what? 24. This will give us what? 2. 1 times 5 will give us 5. This and that will give us what? Plus 30. 7 times 1 will give us what? 7. 7 times 5 will give us 35. Minus 18. 8 times 1 will give us what? 8. The whole of this is going to give us what? So this and that is going to give us minus 7. The whole of this is going to give us 42. The whole of this is going to give us what? 9. Now let's simplify. This is going to give us minus 7 over what? 19. We also have 42 over what? 19. And then we have 9 over what? 19. Therefore, the value for x is going to be minus 7 over 19. The value for y is going to be 42 over what? 19. And then the value for z is going to be what? 9 over 19. As easy as that. So this is how we use the inverse approach to solve three system of equation. See you tomorrow. Bye bye.